Okay, wow, we get to, 5 times 10 to the 30th mutations. Beneficial. Again, a huge number. So, that's a lot. That's more mutations than are found in any genome. Most of them don't survive. Some of them do. So you only need a fraction of a percent of those mutations surviving to account for mutations seen and the divergence and wonderful diversity of animals on the planet. So now if we take a look at the last 1 billion years, and I'm going to use a generation every 2 years here, and a population of about 20 million, really lowballing the population. Really lowballing the population here. Being really nice. And that's just basically 2 times the figure that MackQuigley gave of 10 million potential species. Just averaging it out. Kind of going with the biblical theme. 2 pairs. Whatever. Okay. Using the same genetic figures of roughly the human genome, just to make things easy, which I think is well balanced out by the fact that I'm using a very small population size. And we get, 1 billion years at 0.5 generations per year at 20 million individuals per generation with a genome of 6 billion base pairs and a mutation rate of 10 times 10 to the negative 8th equals a total of 6 times 10 to the 17th base pair mutations, or 6 times 10 to the 15th beneficial base pair mutations. And we're averaging base pair mutations. Remember, that could also mean any other mutation, but it's just an average. Most organisms share a large part of their genome with us, and they share a large part of their genome with each other. So let's just say that the differences are generally less than 50%. So given 3.5 billion years and known mutation rates, there is absolutely no difficulty in accounting for the diversity that we see today with 10 million plus species. And it's actually a lot more species than that if you consider all the ones that went extinct. Again, no difficulty at all. The math is there. Now his final question. Total odds of obtaining 10 million plus unique species from a single cell by random mutation and natural selection in the time frame given, 100%. The math gives us 100% with a huge margin of error. The truth is, you can obtain 10 million plus different species in a much shorter rate, in a much shorter span of time. 5, 10, 15 million years. It doesn't take much. Mutations are very powerful. Natural selection is very powerful. So in the end, whatever you creationists try to argue against evolution on a genetic basis, sorry, it doesn't work. Genetics back up the theory of evolution. The math backs up the theory of evolution. We can measure mutation rates. We can extrapolate from those mutation rates the times it would take, the time that it takes for mutations to occur. Hey, because it's a genetic clock found in the that we use in mitochondrial DNA, or in the human Y chromosome if you're trying to figure out male lineage. And these things are fairly consistent. And when you average them out, they're very consistent. So, is there any problem with genetics in regards to the theory of evolution? Absolutely none. Does the genetics somehow support a creationist model? No way. Do creationists actually make any sense with their claims about genetics and how it somehow falsifies evolution? Not in the least.